Hi, everybody, and Happy New Year. Here on Echo Live today to celebrate some of the cold weather we've been seeing here in Michigan for the past few days, we are going ice fishing. Now, unfortunately, since we are here in the distance learning studio, there is no frozen lake or no ice and no real fish to be found. But instead, we wanted to go ice fishing using science. So we've got a fun activity to show you that ties to this month's theme here at the Michigan Science Center, which is Arctic expeditions. Now, we are going to explore the area of the Arctic all month long, but we'll also be talking about different concepts and tools that scientists use who are involved in exploring these areas that we know of here on Earth and even on other planets. So let's get to the activity. You will get to see this if you stop by the Michigan Science Center any day this month while we are open to the public. Our hours are Wednesday through Sunday, 10 a.m. to 4 p.m. So you can stop by with your school group or your family and you can try this activity out yourself. Now, what do I mean by ice fishing? Now, instead of going fishing for fish, we're actually going to fish for ice. So a little bit of the opposite spin on the phrase. Now, the challenge of this activity is to be able to pick up an ice cube, just like this one, using a piece of string. Now, try as you might, it's a little bit trickier than it sounds, but let's talk about the science and let's give you a tip and trick so that you can actually try this activity at home or here at the Michigan Science Center if you do stop by during the month of January. Now, in order for this experiment to work, instead of leaving my ice cube here on the tray, I'm actually going to drop it down inside my container full of water. Now, this container is really full to the brim, which makes it so that my ice cubes are going to float right here at the top. A little bit of spillage is totally fine for this activity. And now, if I were to try again, if I were to try taking my handy dandy piece of string here and going fishing for one of my pieces of ice, I'm noticing that I'm not having great luck. But I do have one more material here on my tabletop that I need in order for this experiment to work really well. So what I'm going to do is I'm actually going to lay my piece of string very carefully across my ice cube or ice cubes here. And I'm going to let that try to sit as still as possible. Now, my very last ingredient or material for this activity is something called sodium chloride. Maybe you're familiar with sodium chloride, heard of it before. Sounds kind of weird, but this is what we also know as table salt. So I have just a little bit of table salt here in this container, and you can either use a spoon or I'm actually just going to sprinkle a tiny amount of table salt, or again, sodium chloride, across the top of my string, which is sitting on my ice cubes. So the purpose of this activity, we want to use as little salt as possible, and just trying to concentrate that salt right where the string touches the ice cube. Now, we need to give this experiment just a small amount of time, so we want to give it about 30 seconds in order to work. Now, you may know that salt and salt water have a lot to do with each other. When we talk about the water here on Earth, we know that we have certain types of water that we call fresh water and certain pools of water that we call salt water or seawater. Now, most of the world's fresh water is actually locked up in glaciers and ice caps. Almost 70% of the world's fresh water looks like we are back online. Let's see if we can. Perfect. All right, so if we pause there, don't worry, we'll come back later and hopefully we didn't miss too much. But the last thing I said is that fresh water freezes at 32 degrees Fahrenheit or 0 degrees Celsius. But in order to freeze salt water or seawater, we actually need it to be a little bit colder, about 28 degrees Fahrenheit. Now, our activity has had a little bit of time here, so let's go ahead and try this out. If our experiment worked correctly, when I lift up on my string, you'll notice that I'm able to lift the ice cubes up out of the water by that string because the ice cubes have actually frozen to it pretty securely at that. So what's going on? We mentioned that the freezing point of salt water is a little bit colder. So when I sprinkled the salt on top of my ice cubes, it actually allowed those ice cubes to melt because we had salt water instead of purely fresh water. So as that water melted, that water pooled up on top of the string And as that happened, some of the salt actually started to dissipate back into the cup, which didn't leave very much salt on top of the ice cubes. I can actually barely see any salt at all left here on my cubes or on top of the string. And once that salt went away, that freezing point went back up. The freezing point of the fresh water, again, was 32 degrees Fahrenheit. And so actually that water froze again, which actually created this kind of nice fun activity where we actually are able to fish for our ice cubes. So let's talk about what this has to do with us. Now, if you live here in Michigan, you might know that we actually sprinkle salt on the roads. So maybe you do this at home by sprinkling some salt on your sidewalk or your driveway, or if you've seen some of these big trucks driving around the highways, or maybe your city streets, these trucks actually distribute salt in order to lower the freezing point of the water on the road, which makes it harder to turn into ice. So it helps to prevent some hazards. Now, if the salt that we sprinkled on the roads were to do the same thing we did in our experiment here, if it was able to melt and then immediately refreeze, that wouldn't be so great, right? It could cause things to stick to the roads, and we actually wouldn't want that. So let's investigate what that would look like here on the tray. So instead of performing our experiment inside the cup of water, like we tried the first time, let's go ahead and try that here on the tray. So there's no pool of water this time. So when I lay my string across the top and sprinkle just a small amount of our table salt here on the string, making sure that we're making good contact and allowing that ice to start melting. And when you try this here, you'll actually see that melting start to take place. This ice cube is starting to shrink because the salt is lowering that freezing point. It doesn't remain a solid. Instead, it turns into a liquid. But this time, the salt has nowhere to go. So the salt is still just sitting there on top of our ice cube. It's actually just sitting there. I can see our ice cube melting, perhaps a small pool of water created on the bottom here. And we want to give this one about the same amount of time, so maybe about 10 more seconds, so that we can test whether we see the same or a different effect as we saw in our cup. But again, we said that if this were to happen on the roads and our ice cube were to refreeze, that wouldn't be so great. So let's go ahead and test that out. And you'll notice that here, without the pool of water, able to dilute the salt and take it away from our ice cube, that salt is just continuing to melt the ice cube. It's not allowing that water to refreeze on top of the string. And so we can't actually go fishing for ice on the ground. So all month long here at the Michigan Science Center, we are exploring the Arctic. We are talking about the tools and the information that scientists have learned about these areas. And you can try all these things if you visit here with your school group or with your family this month. So thanks everyone so much for joining us again for this week's episode of Echo Live. We'll be here every Wednesday at 2:30 talking about what's going on here at the Michigan Science Center and telling you about some activities that you can try in your classroom or at home as well. So thanks everyone so much for joining us. We'll see you all back here next week for another episode of Echo Live. See you soon.